Your systems essential skill has a few different types of problems to be expected. The first one is these word problems where you have to write your own equations, system of equations, and solve it using algebra. Guess and check is not going to get you full credit on this. In life, sometimes things don't come out to be whole numbers, so you don't always get to guess and check to solve a problem. So in this problem, for some reason you have $25 to spend and you're in a hurry so you can only buy 10 items. Apparently you're in need of sodas and sandwiches. If sodas cost $1.50 each and sandwiches cost $4 each, how many of each can you buy? So you need to look at each part one at a time. You can only buy 10 items, and you're only buying sodas, I'm going to call it X, and sandwiches, I'm going to call it Y. So if you're buying 10 items, the number of sandwiches, X, plus the number of, sodas, X, plus the number of sandwiches, Y, has to equal 10. Then, if sodas are $1.50 and sandwiches are $4, $1.50, 1.5, X, plus 4 for each sandwich, has to equal that $25 that you're spending. We're assuming you're spending it all. So this is my system of equations. A couple different options. You can do elimination. Multiplying the top equation by negative 1.5 would be a good way to do it. Or you could solve the top equation for x or y and plug it into the bottom. If it helps you at all, I'm going to do elimination. So I'll start setting that up. I'm going to multiply the bottom equation by negative 1.5. Do that and see what you get. So multiplying that top equation by negative 1.5, I wrote it down below. Notice the reason I chose to do that was now these are the same number but opposite symbol. So if I add straight down, those cross out. 4 plus negative 1.5 is 2.5y. And 25 minus 15 is 10. Now I can easily solve for y. Divide both sides by 2.5. And y equals 4. Remember, you chose, or I chose, what x and y stand for. So to get full credit on the problem, don't tell me y equals 4. Tell me sandwiches, because we made y be sandwich, equals 4. Remember, we were able to buy 10 items. So if I plug it in my head, if I'm buying 4 sandwiches, I have enough room in my cart to buy 6 sodas, so that I have 10 items total. Okay, our next type of system problem is a system of inequalities. Notice I've got two different graphs, two different parent functions that I'm going to be graphing, but some of them are greater or equal to, one of them, and the other one is less than. So an important thing about this, if you have the equal to bar, so it doesn't matter which way it's facing, it's the fact that it's the equal to bar, that's going to be a solid line. If you're missing the equal to bar, that's going to be a dashed or a dotted line. So I go to graph it as if I would normally, and then before I connect the dots, I stop and think whether it should be solid or dotted. So start with the parabola. Get a sketch of this parabola on your paper. Pause it. So for the parabola, the vertex is at -3, -4, and the vertical stretch, the a value is 2, so I put 2 dots, 2 higher than the vertex. Then I get to sketch it from there, so try to make it look like a parabola, stretched vertically. Then I need to test a point. So my parabola is not going through 0, 0, so 0 seems like a good number to test. So in my original inequality, for y I'll put in 0, and for x I'll put in 0. Then we need to do some algebra and simplify this. 0 is greater than or equal to, this is 3, squared is 9, times 2 is 18, minus 4, 0 is greater than or equal to 14. Remember, it's supposed to be eating, the crocodile is supposed to be eating the big number. 0 is greater than or equal to 14, this is false. So since I tested 0 and it was false, That's on the outside of the parabola, so that must mean the inside of the parabola is true. So it's hard for me to do it on the iPad, but lightly shade or put some stripes inside the parabola. That's half of it. Now we need to graph the line. So I'm going to switch colors. You go ahead and graph the line as if you would in Algebra 1, and then see if it matches mine when you're done. Keep an eye out for solid and dotted lines. So here's my line. The y-intercept was 2 and the slope was up 3 over 1. Then again, I need to test a point. Because 0 is not on the line, I'm allowed to test 0 again. 0 in for the y value. Keep the original symbol. 0 in for the x value. This one says 0 is less than 2, or the big part's supposed to be pointing to the bigger number, which it is. This one's true. So this time for the green line, 0 right here is true. If that side of the line is true, that's the line that I lightly shade or put some stripes on it. And then, important part on the test, make sure you darken where they overlap. This part in the parabola below the line is all the solutions to this system. There's no algebra to solve this. The solution is in the picture, that red part in the picture. If you think you can handle a trick for graphing inequalities, there's only two options. Either y is going to be less than or equal to. The equal to bar doesn't matter right now. The equation. Or y is going to be greater than or equal to, doesn't matter, the equation. If y is less than the equation, remember the y-axis is the vertical axis, and things that are less than, small on the y-axis, are down. So I'll be shading below my line. If it's a parabola, I'd be shading down here. Or if it was an upside down parabola, I'd be shading down from the vertex. If it's a line, I'd be shading below the line. If it's the other way, greater than the equation, the y's that are bigger are up, so I'd be shading upwards from whatever the important point is. If it was a cubic, I'd be shading above that locator point, up here. If it was a parabola this way, I'd be shading above the vertex, up here. If it's a parabola this way, I'd be shading above the vertex. If it was a line, I'd be shading above the line. So if you think you can handle that trick, you can use it, but testing a point is always a safe method to use. Okay, here's our last systems example. We are trying to solve this equation where they said a parabola equal to a line. Often we'll make you graph it also. Realize when we graph it, we just want you to graph the left equation, which is a parabola, and the equation on the right, which is a line. So take a second and graph both sides of this equation. Okay, it's not perfect, but the equation on the left I did in blue, the parabola, vertex at 3, 1. And the equation on the right I did in green, a line, slope of -1, and a y-intercept of 10. This is not going to get you passed on this essential skill, though. You need to be able to do it algebraically. So remember, just the x minus 3 part squared is a small problem you have to do all on its own. Maybe you use an area diagram to do that. Remember, don't kill the puppies. X minus 3 squared is x minus 3 times another x minus 3, which gives me x squared, negative 3x, 9. Just the part in yellow is x squared minus 6x plus 9. But then don't forget the problem said plus one more equals negative x plus 10. Now we've got a quadratic. My x squared is on the left, so we should combine like terms and move everything to the left. So x squared, if I add this x, I get minus 5x. This part is 10, and since it says plus 10 on the other side, when I minus it, I'd get 0, and it equals 0. So you can do the quadratic formula. If you want me to write this in standard form, this is x squared minus 5x plus 0 equals 0. So a would be 1, b would be negative 5, and c would be 0. It's also factorable. It's your choice. See if you can finish solving this for x. So whether you did factoring or quadratic formula, you should have come out with 2 answers, and you should realize that from the graph. My graph's not perfect, but obviously it crosses somewhere around there and somewhere around there, so you should get 2 answers. And then the answers are just x equals. Remember, this equation didn't have any y's in it, so x equals 0 and 5 are my answers.